Good day, dear students. So let us start the lecture number 2. So in the last class, let us have a brief recap. In the last class, we learned about why should we learn the blockchain and the need of blockchain technology. So what is the need? It is an emerging technology for fast, secure, cashless transaction. So in the last class, we also learned about the blockchain architecture. So you are seeing that different blocks are there. Blockchain is a chain of blocks that contains the data. So the data is distributed among different blocks. So blockchain and distributed system. In the last class, we had come to this point that the roots of blockchain are in distributed systems. Means if you want to know what blockchain is, you should thoroughly know what are the distributed systems. So what is a distributed system? As you are seeing, distributed system contains multiple nodes. See here, there are multiple nodes. They are physically separated but linked together using the network. All the nodes in this system communicate with each other and handle processing in tandem. Each of these nodes contains a small part of distributed operating system software. So it is very easy to understand. It is a group of nodes. They are connected through a network. No doubt they are physically separate, but they are linked together through a software. So there are several advantages of distributed system. Some of the advantages are all the nodes in the distributed system are connected to each other. So nodes can easily share data with other nodes. It means one node can share the data with another node. The second, more nodes can easily be added to the distributed system. So it can be scaled as required. And failure of one node does not lead to the failure of entire distributed system. Other nodes can still communicate with each other. These are the few advantages of distributed system. So the most important functions of distributed computing are the resource sharing. What do you mean by this resource sharing? Whether it is a hardware or whether it is a software or whether it is a data that can be shared. The second is openness. How open is the software designed to be developed and shared with each other? Means everything is open as nodes communicate with each other. The third important function is concurrency. Multiple machines can process the same function at same time. Simultaneously, see, multiple machine can process the same function, the same task can be divided, can be completed at same time. That is the concurrency. Next is scalability. How do the computing and processing capabilities multiply when extended to many machines? Scalability means it can be extended. So many, when it is extended, obviously we will get more processing, we can have more processing capabilities. And one important function, that is a fault tolerance. That is how easy and quickly can failures in the part of the system can be detected and recovered. That fault tolerance means, suppose in a centralized system, if the main node is not working, the whole system will be not working. But here, as the data, as if one node is not working, then other node will take care of it. And the last is transparency. How much access does one node have to locate and communicate with each other, with other nodes in the system? That is, the nodes are transparent in distributed system. So these are the few important functions in distributed computing. In that environment, we have got resource sharing, openness, concurrency, scalability, fault tolerance, and transparency. Modern distributed systems have evolved to include autonomous processes that might run on same physical machine but interact by exchanging messages with each other. So these are the very basic thing you must know to understand how the blockchain technology works. The underneath technology, the concept which run behind the blockchain technology is distributed computing system. So understanding distributed system is essential to understanding of blockchain technology, as blockchain is distributed system at its core. It is distributed ledger. In the last class I told you ledger is nothing but, as we keep registers in the bank, the same thing we are having the different blocks where we are saving the information about the transactions. So it is a distributed ledger that can be centralized or decentralized. A blockchain is originally intended to be and is usually used as a decentralized platform. So usually we are going with the decentralized platform. It is a system having properties of both decentralized and distributed paradigms. See, two important things are there. One is decentralization, another is distributed paradigms. It is a decentralized distributed system. Distributed systems are a computing paradigm whereby two or more nodes work with each other in a coordinated fashion to achieve a common outcome. To achieve some task, to achieve some goal, the distributed systems are a computing paradigm where two or more nodes they work together in coordination such that to get a common outcome. So you may be thinking that when we talk about this distributed system, there are so many nodes and they are connected, there is openness, there is a transparency, there is a scalability. Uh, what might be the example? So the example is very simple. We all know, everyone know that is a Google search engine. A Google search engine is a best example for distributed system. So a distributed system is one. It is modeled in such a way that the end users. It is modeled in such a way that the end users see it as a single logical platform. That is, the Google search engine is based on. It is based on large distributed system, but to a user it looks like a single coherent platform. See, any person on any part of the world he can access the Google search engine. We don't know what are his the system from which system he is going to access the Google. It may be what type of hardware he is using. So whether it is a Windows, whether it is a Mac, or whether it is a Linux, whether it is a Unix. So, but the thing is, it is working. So it is modeled in a such a way that the end users will see a single logical platform. That is the best example of distributed system is a Google search engine. So when we come across a Byzantine's general problem. That problem comes under this distributed system. That problem we are facing in the blockchain technology also. So when we talk about node, a node can be defined as an individual player in a distributed system. All nodes are capable of sending and receiving messages to and from each other. Nodes can be, see, when we talk about distributed system, it is very much clear that we have n number of nodes. So now we focus upon how the nodes are. Nodes can be honest, nodes can be faulty, or nodes can be malicious, and they may have, anyhow, their capabilities. Every node has got memory and processor. But the thing is, when we talk about the behavior, they may be honest, they can be faulty, or they may be malicious also. A node that exhibits irrational behavior is known as a Byzantine node. Let me repeat. A node that exhibits irrational behavior is known as a Byzantine node. So you may be thinking about this general Byzantine general's problem. What is this general? So this general is nothing but it is a military general. So we'll see some simple example. See, in 1982, a thought experiment was proposed by Lamport and others in their research paper, The Byzantine's General Problem, whereby a group of army generals who lead different parts of the Byzantine army are planning to attack or retreat from a city. The only way of communicating among them is via a messenger. They need to agree at the same time in order to win. The issue is that one or more generals might be traitors who could send a misleading message. Therefore, there is a need for a viable mechanism that allows for agreement among the generals, even in the presence of treacherous ones, so that the attack can still take place at the same time. Same analogy we are applying to the distributed system. As you are seeing, suppose there are four journals, 1, 2, 3, 4. So the thing is, they will win if they are at the different positions, different locations. The only thing that will make them win is, suppose they attack at exact, some time is there, suppose they have set one time, at that time only, if four people they attack, then only they will win. If three attack or two people attack at the time, they will not win. So the condition is that information about exactly at what time so they should attack, that is kept as a confidential and everyone should obey that. In this way they can win. But unfortunately, as I have told, few nodes are honest and few nodes are malicious. Suppose node 3 is malicious, so he is not going to attack at the same time as decided by all 3 4. Suppose he is malicious or he can tell some other time to this node 2 or node 4, then definitely they are going to lose the war. So that is the Byzantine problem. Now we will see how this problem can be solved. The primary challenge, see, I think it is now visible. The distributed system has 6 nodes, N1, N2, N3, N4, N5 and let it be N6. This distributed system has 6 nodes, out of which one N4, see here, this is N4, it is in different color, orange color. So N4 is a Byzantine node leading to possible data inconsistency. L2 is a link that is broken, that is also one of the problem, or slow, that can lead to partition in the network. See, there are two problems. One problem is there is a one traitor, there is a one malicious node, that is N4, and there is a broken link. So now how we have to solve this, we will see. So the primary challenge in the distributed system is a coordination between the nodes and fault tolerance. Even if some of the nodes become faulty or network links break, the distributed system should be able to tolerate this and continue to work to achieve the desired result. This problem has an active area of distributed system design research for many years, and several algorithms and mechanisms has been proposed to overcome these issues. So there is one theorem that is called cap theorem. Distributed systems are so challenging to design that a hypothesis known as the cap theorem has been proven, which states that the distributed system cannot have all three of the much desired properties simultaneously, that is consistency, availability and partition tolerance. So this made this cap theorem: consistency, availability and partition tolerance. So how this problem can be solved? This problem can be solved the Byzantine fault tolerance algorithm. This problem was solved in 1999 by Castro and Lisco, who presented the practical Byzantine's fault tolerance. So there was a consensus is reached after a certain number of messages are received containing the same signed count. Means 4. So we were discussing this distributed system has 6 nodes, out of which N4 is a Byzantine node. Means this is malicious node, leading to possible data inconsistency. L2 is a link that is broken or slow, and this can lead to partition in the network. Means 2 different type of data will be there because of this problem. So how we are going to solve this? So the primary challenge in distributed system design is coordination between nodes and fault tolerance. There should be a coordination between nodes and there should be some fault tolerance. Even if some of the nodes become faulty or network links break, the distributed system should be able to tolerate this and continue to work to achieve the desired result. This problem has been an active area of distributed system. Means how we are going to solve the problem. Since many years, researchers are working on this problem, and we have got several algorithms and mechanisms that has been proposed to overcome these issues. So there is one theorem, usually we call it as a cap theorem. So distributed systems are so challenging to design that a hypothesis, you know what this hypothesis is? Means we consider it as the cap theorem, as has been proven, which state that a distributed system cannot have all 3 of the much desired properties simultaneously. What does it mean? When we see the ground reality, it is very much impossible for a distributed system to be consistent, and second is every time the data is available, and there should be a partition tolerance. So these 3 are very important factors that make a system to work properly. So no doubt in a practical scenario, so many algorithms have been developed to solve this issue, but these 3 at one time, these are the much desired properties of a distributed system. One is consistency, another is availability, and last P for partition tolerance. And just we have seen about this 4 generals problem. So how we are going to solve this problem? This general problem, how we are going to solve this? We know that these 3, the third general is a traitor. So he is a one who may be the reason for the failure. So how we are going to solve this? One solution they have come up. That solution is, this problem was solved in 1999 by Castro and Lisco, who presented that the practical Byzantine fault tolerance, they have proposed one algorithm where consensus is reached after a certain number of messages are received containing the same signed content. What does it mean? So if there are n number of nodes, there will be a consensus. What does this mean by consensus? They will see that what the majority of the nodes tells us. Means we will go by majority and minority. We will go by consensus. So if suppose majority of the node tells that data, then that data can be considered as a correct data. Otherwise, if there is no consensus, we can think that the data has been corrupted. So thank you for this. We will continue the history of this blockchain technology in the next class. Thank you.